there are n number of nodes in the tree structure, then there is a maximum of n minus 1 links. In a tree's data structure, the first node is called as a root node. What is that? The root node. Every tree must have a root node. Without root node, we cannot build any tree. Leaf node, which does not have any children, are called leaf node, or we can call it as terminal node also. It is also called as external node or the terminal node. Hello everyone, welcome to the one more session on data structure using C for second semester B.Ca student. We'll be continuing the discussion on Unit 3. Myself, Induje, Faculty of Computer Science Department, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. Continuing the discussion on the Unit 3, we have already seen different types of data types. Now we are moving to the very last type of data type for your syllabus, that is a tree. What exactly tree is and what all the terminologies we are going to use when we are using the trees as a data structure, that we are going to discuss in this particular session. Right, let us start. So what is tree? As once we say tree, what you are imagining of? Imagining of this tree? No, this data structure tree is not as that of this tree. Tree here, it goes in an upward direction, but in the data structure, what the tree we have, it will grows in downward direction. Okay, tree is a non-linear data structure. Okay, that means we don't have a continuous memory allocation when we are dealing with the trees. It's a non-linear and non-primitive data type. So tree structures follows the recursive pattern of organizing and storing the data. Why we are using trees? Because most of the tree patterns will go with the recursive function. What is the advantage of recursive function? We have already discussed in the Unit 1. Why? Because recursive functions makes the coding easy. And we can do it repeatedly, the same set of the code, the length of the code will be reduced, hence the memory efficiency and time efficiency we can achieve. Then tree is a very popular data structures used in the wide range of applications. Just now I have quoted you, in many applications we are using a tree data structures. Next, see where exactly tree lies. When we are dealing with the data types, we have a non-primitive data types. In the non-primitive data types, we are having linear and non-linear data type. In the linear data type, we have already discussed array, stack, queue and a linked list. Now what we are discussing is tree. That is a first non-linear data structure. Only we have a tree for your syllabus, so we concentrate much on trees only. So how to write the tree? This is how we can write the tree in different ways. Fine. So you can represent the tree like this, either like this, like that. There are plenty of methods to represent a trees. What tree consists of? Tree consists of set of nodes and the edges. What is this called as node? We know what the node is. Node holds the actual data, and these edges, whatever we are having, this will provide the connection between one node to the other node. That is called as edges. As I quoted you in the first slide, tree grows in downward direction. Here this particular first element of the tree, that is called as root, and it will goes towards a downward direction having the different branches. Okay, understood what is a tree? Tree is a non-linear data type where we have a collection of nodes and edges. Fine, and always tree goes in the downward direction, and most of the time tree works on the recursive function. Is unclear? Yes, very good. Next, these are all, you can represent anything, you can take any node, any data, and each node has to be connected with the edges. That's how we are going to represent the tree in diagrammic representation. Okay, next have some more information on trees. Every individual element is called node, right? As we have mentioned, every individual element is called node. Node in the tree data structure stores the actual data, what the element or the character or the string, whatever you want to store, that will be stored, actual data will be stored in the node. And the particular element of the next element will be hierarchical structure. What structure we are having? We have hierarchical structure, level by level, one level after the other level, that is called as hierarchical structure. So whenever we are representing the tree, we represent in the form of hierarchical structures. There are n number of nodes in the tree structure, then there is a maximum of n minus 1 links or the edges, we can say. So how many, if I just for simplicity, I'll take only the small tree which is having 3 nodes. So what the statement says, if there are n number of nodes, n minus 1 edges should be there, maximum of n minus 1 edge should be there. So how many nodes I have? I have 1, 2 and 3. So how many edges I should have? N minus 1. What is my n value? That is 3 minus 1, that is equal to 2. Only we can have 2 edges. That is what we are having, 2 edges. The line that connects between one node to the another node is referred as a edge here. Okay. Next, what we have is, if any tree with the n nodes, there will be the maximum of n minus 1 edge. So here they have given the examples. If there is 11 node, this is what we have, 11 node, then how many edges should be there? 11 minus 1. What is 11? N value is 11. So 10 edges should be there. How we are calculating? E is equal to n minus 1. What is E? E is a number of edges. Number of edges. So that's how we are going to calculate. You got to know what is node and what is edge now. Let's move on to the different terminologies what we have when we are dealing with the tree. First and the foremost thing, tree should have a root, right? Without root, no tree will stand off. That's why the first terminology, what is root? With respect to the data structure, which is a root? The first element of the tree is called as root, or first node of the tree is called as node. In a tree's data structure, the first node is called as a root node. What is that? The root node. Every tree must have a root node. Without root node, we cannot build any tree. A root node is the origin of the tree structure. As we don't have anything here, so this is a root node. So we can say that root node is the origin of the tree. In the given example, A is a root node. Fine. Then what comes with the edges? We have already discussed. What is edges? That line connecting between one node to the other node is called as edges. The connecting link between any two nodes is called edge. If the tree has n number of nodes, then there will be the maximum of n minus 1 edges. That's what we have discussed in the last slide. Then next, what terminology we have is parent. Who is a parent? Parent is a one who has a children's, right? So obviously the root have children's, then it is a parent node also. Root node can also be the parent node, but all parent node cannot be the root node. The node which is a precedence of any node is called as parent node. Node that have some successor or precedence is called as parent node, or the node which has a branch from it to the other node is called as parent node. Okay, so you can make a note that node which have a branches to some other node is called as parent node. In this particular example, which all the nodes can be the parent node? As mentioned, root node can be the parent node, and node B, because it has a children here. Some other nodes are connecting to that, so this can be the parent. C can be the parent. E can be the parent and G can be the parent node. Why not D, I, E, F, G and H are the parents? Because from that particular node, no edges are going out. It's not connecting to any other node. So it don't have a child. That's why it is not the parent node. Then what comes with the child node? Then obviously who has a parent, that is called as a child node. The node which is descendant of any node is called as a parent node, is called the child node. Node which is a descendant of any node is called as a child node. So here in this example, B and C are the children for A and D and E are the children for B. Like this, whichever the node that come from the parent node is called as a child node. Or we can state that the node which has a link from its parent node is called a child node. In this particular tree, what all the child node? A for B and C are children for A, and D and E are children of B. F, G, H are the children of C. Like this, you will be having the child node. Fine. So next, here we have a J and K are the children of which node? Node J, which is a parent node, and I is a children of which node? E node, which is a parent node again. So clear what is a parent and what is a child. Next, what we have is siblings. As you all people will be having siblings, nodes in the tree will also have a sibling. Who are the siblings? That are in the same level. Okay, that is called as sibling. If A is a parent node, B is a child node, C is also the child node, then how do you connect B and C? B and C are siblings. Nodes that are from the same parents, that is called as siblings. Node which belongs to the same parent is called as sibling, right? In simple words, the nodes with same parent are called siblings. Here we can say B and C are the child of A, where B and C are siblings to each other. Here also we can say D and E are siblings to each other because both will be having the same parent. Here F, G and H, three are also the siblings because they are having the same parent. But I does not have any sibling. I is a single child node. Okay, that is what about the siblings. Then what is a leaf node? Leaf means it should be the last node of the tree. Where leaf will be there in the trees, that will be in the last nodes of the branches. So, at the last position of the branches, leaf. Similarly, here also we have a leaf node. Leaf node which does not have any childrens are called leaf node, or we can call it as terminal node also. It is also called as external node or the terminal node. Here we don't have a children for the node D, node E, F, H and K. So these all nodes which we don't have a childrens to it is called as leaf node, or you can say that we don't have any out degree. Node that don't have any out degree is called as a leaf node or terminal node, or it also be can called as external node. External node is also node with the no children in the tree, and it is also called as terminal node. So in this example, what are the leaf nodes which don't have a further children? That would be the last end of the tree, end node of the tree. D, I, F, G, K and H are the leaf node in this particular example. Then what comes with the internal node? The node which is not the root node and node which is not the leaf node. Intermediate, whatever the nodes are there, that nodes are called as intermediate node. The node which is not the parent node or the root node, and the node which has at least one child is called the internal node. Node that has at least one child. Here what all the internal node? B, E, G and C. The parent node can also be the internal node but not the root node, and leaf node cannot be the internal node. So the root node is also said to be internal node if the tree has more than one nodes. The internal nodes are also called as non-terminal nodes. As we have given the name for the leaf node as a terminal node, internal node is also called as non-terminal node. So what all the internals node we have? A, B, C, E and G are the internal nodes what we can have in this particular example. Next terminology what we have is degree of the node. What is the degree of the node? The total number of children of the node is called as degree of the node. How many children a particular node is having, that is called a degree of the node. When it comes to the degree of the node, we have in degree and out degree. What do you mean by in degree? In degree is the one how many edges are coming inside to the node, that is called as in degree. Coming inside to the node is called in degree, and how many edges are going out of the node, that is called as out degree. What is a degree? First of all, how many children a parent is having or the node is having, that is called as degree. Here for example, if I take the node A, how many children the node A is having? It is having B and C. So degree of this is 2 because it is having 2 children. So what is the in degree for A? Hence it is a root node. We don't have any in degree, no in degree. There is no in degree for the root node and there is no out degree for the leaf node. No out degree for leaf node. Okay. And when coming into the example, in the node B, how many in degrees are there? 1 in degree and 2 out degrees are there. Right? Similarly, for the C, how many in degrees are there? 1 in degree and how many out degrees? 3 out degrees are there. So, what is the degree of this particular node C? C is having degree 3 because it is having 3 childs, and B is having degree 2 which is having 2 child. Okay, that is what about the degree. Then what we have is level of the tree. What is the level of the tree? Level of the tree, as tree starts with the root node, we have to start the level from the root. That is called as 0 level. We indicate the root level as a 0 level. The root node is said to be at the level 0 and the children's from the root node are at the level 1. As we have stated, the tree is a hierarchical representation. As hierarchy goes more, the level will be increasing. So level means it should have 0, 1, 2 and 3 levels. All the nodes that forms in the single level is called the level of the node. So in a simple words, the tree, each step forms a top to bottom is called as a level. When we are forming the tree, we have other levels for that particular tree. Next what we have is height. Height of the tree. What is? The number of level is equal to the height of the tree. Okay, how do you represent? If I have A, B, C, D, like this. What is the height of the tree? How many nodes that are connected from the root node to the leaf node? From the root node to the leaf node. That is called as height of the tree. The number of nodes that is connected from the root node to the leaf node is called height of the tree. Total number of edges from leaf node to the particular node in the longest path is called the highest node. So when we are considering from A to D, it is a longest path, that is a highest value for the height. If I consider from node C, that is a height of the tree from the node C to the leaf node. In any tree, height of the tree is a height of the root node. We always represent height of complete tree from the root node to the leaf node. So in this example, what is the height of the tree? We have 0, 1, 2 and 3. So height of the tree is 3 here. Next what we have is depth of the tree. Depth of the tree is highest depth of the any leaf node in the tree is said to be the depth of the tree. In the tree, depth of the root node is 0 and here the depth of tree is 3. Depth of only the root node is 0 and how long it will go, that is called as depth. How deeply it is going, how deeply it is branching out is called as depth of the tree. In any tree, depth of the node is a total number of edges from the root to that particular node. What is this? Total number of edges, how many edges are moving from the root node to that particular specified node or to the leaf node is called as depth of the tree. Next what we have is path. How we are traversing, that gives you as a path. How we are traversing array and then a linked list, we can traverse a tree also. And when we are traversing, visiting each node of the tree, we give the path of the tree. The sequence of the nodes and edges from one node to the another node is called path. Sequence of nodes and edges from one node to the another node is called path. The length of the path is total number of the node in that path. In the below example, what is a path to reach the particular node I? From A, I am going to node B. From node B, I am going to node E. From node E, I am going to node I. That is called as path. From A, node, edge, then B node, then edge, then E node, then edge. Then we are reaching to the required node, that is ith node. Path is what? A sequence of the nodes and the degree between the two nodes. Here the path of A and K is like from moving from A to K. What is the path for A to K? We can move from A to C, C to G, G to K. So this is a path what we have for reaching the node E. That is nothing but traversing to the particular position or the particular node of the tree is called as path of the tree. When we are traversing, we should represent which node we have visited and which edge we have followed. That is called as path of the tree. Then subtree. What is tree? We got to know what is subtree. Here if it is a root node, A is a root node, right? So for the root node we have two subtrees. One is a left subtree and then the right subtree. This is a left subtree and this is a right subtree. Okay. So what is subtree means? Each child from the node forms a subtree. Each child from the node A forms its own subtree. And every child node will form a subtree, its parent to the node. The ancestors of the node are all the nodes along the path from the root. What is the ancestor for B? Ancestor for B is A. Ancestor for E is what? B and A. Like that. Whatever the parents node will get, we call it as ancestors. And whatever the child node will call it as, we call it as a descendant or the successors. Okay, these whatever we will get above, it is called as ancestors, and whatever we get below, those are called as descendant or the successors of the particular node. Example, ancestor of J. What is ancestor of J in this particular? Ancestor of J is C and A. Except the parent node, whatever we get in the path, that is called as ancestors. So forest is a set of disjoint of tree, that is B and C. So got to know what is a subtree. Subtree is from the node whichever the child will go, that will forms one more tree. That tree is called as subtree. When we go with, we'll be having left subtree and right subtree. What is left subtree? Will be having the left child having its own tree. Further, it is called as left subtree. And from the right child of the parent having its own tree is called as right subtree. So these are all the some of the terminologies what you should know when we are dealing with the data structure called trees. Hope all of you clear with all the terminologies what we have so far discussed. Thank you.